The early history of our planet has been obscured by mystery since the dawn of man, and continues to be a topic explored in hopes of uncovering Earth's beginning. It's a tale of miraculous science in which space and time came together perfectly to create life on Earth. But how did it happen? This is the first question we must ask ourselves to unravel the timeline that led to life on Earth. 26.7 billion years ago, a tremendous explosion called the Big Bang sent out an immense cloud of gas and dust, forming a solar nebula, which triggered the formation of the planets. Earth owes its existence to this fateful event, though the planet would have looked very different at its birth. After the creation of the planets, there was still a large amount of debris in space. As materials from space collided with Earth, the heavier materials sank into the planet's core, while the lighter materials stayed closer to the surface. The planet was still in the process of forming when a large mass hit Earth, causing a piece of it to dislodge. This became our moon. Once the mass that would become the moon had left Earth, it began to be formed in the same way Earth had been, taking impact after impact from the materials in space. As it developed into the moon we know today, it began to affect the Earth with its gravitational pull. The formation of the atmosphere is also one of the pivotal moments in our planet's history, as it would prove to be one of the building blocks of life on Earth through the creation of oxygen. It was formed by meteorites impacting the Earth, which caused volcanoes to form and brought magma from the center of the Earth to its surface, allowing for oxygen to be present. Once oxygen was present, water could form. Finally, there were oceans on Earth. The gravitational pull from the moon affected how these oceans worked, creating tides that would change over time as the Earth and moon developed further. Large storms occurred due to the new atmosphere. Hurricanes and tsunamis ravaged the planet's surface. Today, it has many layers that sustain oxygen levels and block harmful UV rays from the sun, allowing life on Earth to thrive. It also plays a significant role in regulating Earth's weather, which is why weather patterns today have been changing as pollution affects the atmospheric layers. As the Earth continued to cool, massive rock plates moved around the Earth's surface, creating mountains and spurring volcanic eruptions. These volcanic eruptions would lead to reefs in the oceans. Life began to form as tiny microbes and bacteria about 3.7 billion years ago, thanks to the radiation of the sun and ocean vents in the sea. These tiny microbes would feed on methane gases in the Earth's oceans. There's evidence of small structures these microbes would make called stromatolites. Though this evidence is helpful to scientists seeking to understand our planet's early life forms, the rare living reefs of stromatolites are much more helpful, allowing scientists to observe them in life rather than in death. Finally, Earth could sustain life, but it wasn't yet what scientists would consider habitable. This changed when a cyanobacteria could turn light into energy to produce oxygen, making photosynthesis a possibility. The oxygen released by these cyanobacteria caused a mass extinction among anaerobic bacteria. This event was named the Great Oxidation and would have been the cause of the first mass extinction on Earth. Scientists can see that this occurred 2.4 billion years ago due to oxidized iron bands and rocks from the time period. At the same time the Great Oxidation occurred, microbes began to do things differently. They had never been complicated creatures, existing as single-celled organisms, but around this time period, they started to live inside one another. From this, mitochondria developed and allowed for more complex creatures to evolve. For the first time in history, DNA was stored in the cell's nuclei, and cells began to live close to each other for survival reasons. This relationship would evolve into multi-celled organisms. The Great Oxidation, as the event is called, also marks the beginning of the first ice age, roughly 2.4 billion years ago. At this point in time, oceans froze and volcanoes lay dormant. New life, like amoebas and paramecium, evolved and began to feed on plant matter. Eventually, life continued despite the ice age. Fungus, worms, fish, and shellfish began to evolve. An early form of sharks evolved at this stage in Earth's history. Mammals and amphibians that could move on land evolved. These amphibians are sometimes considered the first of the dinosaurs. As oxygen levels increased dramatically, large species of insects appeared. The oxygen levels at the time also increased the amount of plants. The Carboniferous period was the first tropical period on Earth, and much of the plant life that developed at this time is similar to the plant life still found in tropical regions of the planet. All of the plants that grew during the Carboniferous period turned into coal deposits, now used as a fuel source. Reptiles flourished in this time period and became varied as both carnivorous and herbivorous. The crocodile evolved in this period. 2.1 billion years ago, the land on Earth was massed into a single continent called Pangaea in the Permian period. This occurred around 50 million years before dinosaurs roamed the Earth. The number of large animals increased at this time, though they were closely related to mammals and are usually not considered dinosaurs. Examples of these creatures are Gorgonopsians, similar to modern bears, and saber-toothed tigers. The Permian period came to an end when an asteroid hit Earth 250 million years ago. This asteroid devastated life on Earth, sending entire species into extinction. About 541 million years ago, there were a plethora of creatures living at the bottom of the sea that went extinct due to reasons scientists have not yet discovered. Fossils indicate there may have been a new species that attempted to burrow into the sea floor, aerating the sediment and changing the ecosystem. Some changes in Earth's ecosystems benefited creatures and allowed for their continual survival and evolution, while some changes decimated entire species. Innovation for some was a death sentence for others, yet life continued. The creatures that managed to innovate their ecosystems ushered in a new era called the Cambrian period. Many of the new life forms at this time were burrowing animals with hard shells. Hard shells helped these creatures change their ecosystems to fit their needs rather than changing to fit the ecosystems. Humans came late in the overall history of life on Earth. Being evolutionarily primates, we shared a common ancestor with chimpanzees and gorillas, which lived roughly 8 million years ago. The majority of human evolution occurred on the continent of Africa. Humans today are Homo sapiens sapiens, but there were many species of Homo sapiens in the beginning, with scientists estimating 15 to 20 individual species. However, there is much debate over what happened to the other species of humans. Early humans ventured out of Africa and into the rest of the world about 2 million years ago when they crossed into Asia. Early humans entered Europe about 1 million years ago. Australia and the Americas are estimated to have been inhabited for the first time about 30,000 to 60,000 years ago. Humans were constantly moving, mainly living nomadic lifestyles until the invention of agriculture around 12,000 years ago. With agriculture came civilization. Once civilization was established, people had less reason to move around. These civilizations would be the foundations of humanity, paving the way for cultural distinctions based on geographical locations. Humans have played a significant role in life on Earth and have been the cause of many extinctions throughout our history. Not only have humans impacted the flora and fauna of Earth in extreme ways, but also the atmosphere, which is essential to all life on Earth. Humans, however, have the advantage of cognitive intelligence and therefore have the power to reverse any damage they have caused to the planet and its ecosystems. This is a luxury that species of the past haven't had and may be necessary for human life to continue on Earth. Once, life consisted of only tiny single-celled organisms, but under the right conditions, life was able to flourish into the flora and fauna of the planet we know today. The history of life on Earth is a mysterious and complex story found in the rocks and oceans of our world. The story is long, but we are fortunate to play our part in the evolution of life on Earth.